Hello dear students, today we are going to discuss about partition coefficient. What is partition coefficient? This concept is related with immiscible solvents, two immiscible solvents and one solute which is soluble in two immiscible solvents. Now, for example, consider solvent A and solvent B, and these two solvents are immiscible solvents. If we mix these two solvents, we shake and we keep aside, there is separation of two layers of solvent A and solvent B. There is one solute X. This solute X is soluble in solvent A and solvent B. Now suppose we take equal quantities of solvent A and solvent B, and we dissolve solute X in the mixture of solvent A and solvent B. Now you see this table. In first column, quantity of X, solute X, added to mixture of solvent A and B. Suppose we add 10 gram, 20 gram, 30 gram and 40 gram. Second column, concentration of X in solvent A. We added X in mixture of A and B. Then there is distribution of X in A and in B. Third column is concentration of X in solvent B. And last column is the ratio of concentration of X in A and X in B. Once we take example, you will understand. Suppose when we add 10 gram X in mixture of A and B, out of this 10 gram, 6 gram goes in A and 4 gram goes in B. If we add 20 gram, out of 20 gram, 12 gram goes in A and remaining 8 gram goes in B. If we add 30 gram, 18 gram goes in A and 12 gram goes in B. If we add 40 gram, 24 gram goes in A and 16 gram goes in B. Now see, if we take a ratio, the ratio of concentration of X in A and concentration of X in B. This is 6 by 4, and so this ratio is 1.5. 12 by 8, ratio is 1.5. 18 by 12, ratio is 1.5. And 24 by 16, ratio is 1.5. So this constant ratio, that is 1.5, is called partition coefficient. So the constant ratio of concentration is partition coefficient. There are some limitations of this concept of partition coefficient. First limitation is two solvents must be immiscible. If those two solvents are miscible or partially miscible, then this concept is not applicable. Second limitation is constant temperature. Since partition coefficient depends on concentration of solute in solvent, that means it is related with solubility, and you know solubility depends on temperature. If temperature changes, solubility will change, and in turn partition coefficient will change, and that's why temperature must be constant. Third limitation is molecular state of solute in two solvent must be same. That means if solute exists as separate entity, for example solute X exists as X in A, it should be exist as X in B. If two molecules of X associate in the form X2, it must exist as X2 in A and it must exist as X2 in B. If three molecules associate and forms X3, it must be exist as X3 in A and X3 in B. That means molecular state of solute must be same in two solvents, otherwise this concept is not applicable. And fourth limitation is solutions must be dilute. If after adding solute in solvent, whatever solution forms there, if that solution is concentrated solution, this law or this concept of partition coefficient is not applicable, it is applicable only for dilute solutions. Thank you.